Find the exponential Fourier series of this periodic square wave signal W of t. Periodic signals can be expressed as an infinite sum of complex exponentials. These have coefficients ak, and the exponentials have frequencies that are multiples of the fundamental frequency omega naught of the original periodic signal. This begs the question, what is omega naught for this square wave signal we see? Well, it repeats itself every 2 pi seconds, so its fundamental period, t naught, must be 2 pi, and so omega naught, the fundamental frequency, will be 2 pi over 2 pi, or 1 radian per second. So let's substitute omega naught equals 1, and that makes the sum a little bit simpler. Okay, let's now spell out a few terms of this summation so we can get a better idea of what's really going on. We have a0 e to the j0 t, which is just a0, since e to the 0 is just 1, and this is what we call the DC component, or the constant component of the signal, because its frequency is 0, so there's no oscillation. It's the constant part. The next term is a1 e to the 1 jt, and the next is a2 e to the 2 jt, and the list goes on and on. Each of these terms is a harmonic, a certain multiple of the 1 radian per second frequency, the fundamental frequency of W of t. The objective now is to find those coefficients for all values of k, which, if you've noticed, can be negative as well. So, how do we get those coefficients ak? The definition is 1 over t, the fundamental period, times the integral over any period, any interval of length t, and the integrand is W of t, the periodic signal in question, times e to the negative jk omega naught t dt. Remember, omega naught is 1 radian per second in our case. The period is 2 pi seconds, so we have to select an interval of length 2 pi to integrate over. We can choose 0 to 2 pi, but the problem with this is that we'll have to split the integral. 0 to pi over 2 would be one integral, and then 3 pi over 2